boo, boo. Oh, I didn't realize the video started. I was just pretending to be a Doppler radar. And that's how Doppler radar works. So you got that satellite dish, right, as we saw. What is it actually doing? It's sending out energy. And what it does is it sends out some energy in the form of radio waves. So here I am, Doppler radar, boom, I sent out my little burst of radio waves. But you know what it cares about? Not that it sent out the energy, what's coming back. It measures how much of that energy gets reflected by an object that's out in the distance. The more of that radio wave that comes back to the Doppler radar, well, the bigger the object is. The less that comes back, the itty bitty, the smaller the object is. So what a radar does is it moves around, constantly sending out radio waves as it moves in this level. And then it monitors how much energy is coming back as it does that. And we got this level complete, so now we're going to go up a little bit more. And then we're going to go a higher elevation in the sky. And essentially we keep going up a little bit more and go around, around, and around. And really what we're doing is we're looking at each layer in the sky as we go higher and higher and get more information. So that's what a radar is doing. Ooh, that made me a little dizzy, I gotta tell you. So it's measuring how much energy is coming back. That is the main driver of a Doppler radar. So here's exactly what it's measuring. We use a scale of decibels to determine how much energy is coming back. And let's think about hail. If I send out energy and I hit hail, which is big compared to raindrops, right, and thicker and denser, more energy is going to bounce back to the Doppler radar, and I'm going to go, oh, I got more energy. So the Doppler radar is set to say the more energy it gets back, color it a little differently. So on Doppler radar, the darker the colors, really the warmer the colors, that means the more energy that's coming back. We associate yellow and orange and red with heavy rain. That's because heavy rain are big, fat raindrops. What's hail? Even higher on the scale, usually purple or fuchsia. That right there screams hail. Anytime I see purple on Doppler radar, I know it's hail. So that's how Doppler radars got their start, and a lot of them went across the country in 1988. That was the one that pretty much is still in use today. But then they got a major tune-up, a major upgrade around 2010. What's called dual polarization. So instead of just sending out the energy like this, now the energy is coming out like this. I don't know how to point the fingers to do it. It's like a cross section. So now you're really getting like a complete scan. Instead of just getting data like this and then you got to go up again, scan a layer that way, you're getting both vertical scans as it moves and horizontal scans. You know what that's doing? That's giving you a cross section to really narrow in and tell you exactly what's the shape of that object. So what that does is it's made our Doppler radars better, because remember, they don't know if it's snow or if it's hail. They're just estimating what it is based upon how much energy is coming back. But when you have a cross section like that, you're kind of doing like this cross scan of the sky. It's almost like an ultrasound. You're really getting a picture of what's out there. And here's how we use that information. In particular, this update to Doppler radar got us what's called correlation coefficient. If you've ever taken statistics, you've probably heard about correlation coefficient. Here's all it means. The more objects are the same size, the higher the correlation coefficient. The more objects are different sizes, the lower the correlation coefficient. Correlation just means about the same. So coefficient is just a fancy word for number. So if it's all about the same, imagine that would be a higher number. So here's what we're looking at. This is the regular Doppler radar image you see on TV. This is snow, the blues. This is a wintry mix, so snow and sleet. And this is rain, the yellows and the greens. So this is the rain-snow line, which means snowflakes, they're going to be light and less dense. They're going to send back much less energy than raindrops. Raindrops have more density. So there's different things going on here in the sky. Well, we can definitely tell that when we look at correlation coefficient, because you see this big old reflectivity area where it's very bright, it's closer to 1. That just means the objects are different sizes. And when you have a bunch of objects of different sizes, what could that be? Well, we know it's rain here, we know it's snow there, and look how it's the same color where there's snow, look how it's the same color where there's rain. This tells us that it's more than just snowflakes or just raindrops. That's where your wintry mix is. And that's the benefit of being able to get those cross scans. And you know, that's helpful too if there's debris from a tornado. That's going to be much different than, say, raindrops, right? So pretty much these slides just explain what we're seeing. And here's another example. Snow, there's some rain, there's your rain-snow line. And look, on the actual correlation coefficient, this is where the objects are different sizes. I think that's pretty cool. And I'll actually use this on TV. This helps me. So here's what I do. I use it to detect hail. Even though our computer estimates if there's hail, here's what I did. I took our little window right here, and anywhere I put this over, it'll give me that data. Well, remember, if we see the bright colors, and we'll go back, if we see bright colors, that means objects are different sizes. So like hail and rain. If we see the same color, like a red, that means everything's the same size. So same color, pretty much. Ignore the outside edge. That just means it's all rain, okay? Ooh, I see a little purple on radar. Anytime I see purple on just regular reflectivity radar, that's the name, by the way, reflectivity, for when radar hits an object and the computer just displays how much energy comes back. The more energy comes back, the brighter the colors, usually the bigger the raindrops. Or in this case, hail. If I see purple or fuchsia, that means hail. I'm going to take my correlation coefficient and let's see if we see some white or different colors. Oh yeah, it's not just red, that'd be rain. Look how the colors are different here. That means rain and hail. So that's really helpful for me to have that cross scan because I can get better information about storms when they're crossing over Pennsylvania. So I appreciate the new updates to Doppler radars.